Good morning, grade 12. This is Mrs. Pascal. Today's lesson is definite integrals, part 1. The objective of this section is to define a definite integral and calculate some simple forms. Let's define the definite integral. The definite integral, denoted by integration over a lower bound a and upper bound b of f of x dx, represents the calculation of the area between a function f and the x-axis bounded between two vertical lines for x equal a and x equal b, where a represents the lower bound and b represents the upper bound, as shown in the figure. The calculation of definite integral is similar to the calculation of indefinite integral, but in the calculation of definite integrals, there is no constant in our answer. So the integral of f of x dx over the boundaries a, b is equal f of b minus f of a, which means after calculating the function, the integration of the function, as we learned before, we replace first by the value of the upper bound minus the value of the lower bound. So in this section, we will use the same rules of calculation of integrals as calculation of indefinite integrals. The application of definite integrals in calculus is to determine the area bounded between the curve and the x-axis and two vertical lines. So let's take an example. To calculate the area of the colored part, we need directly to introduce the calculation of the definite integral. Since y is equal to x cubed, so f of x is expressed as x cubed, and the shaded or colored part is bounded between the value 3, which represent the lower bound, and 5, which represent the upper bound. So we can directly write a is equal integral over 3, 5, x cubed dx. By using the power rule of integration, we get x4 over 4, and this integral should be calculated over the boundaries 3 and 5. So first we replace by 5, so we get 5 to the power of 4 minus 3 to the power of 4 over 4. Then we calculate the numerical value of the area, which gives 544 over 4 units square, since we are expressing an area. So the area finally of the color part will be 136 units square. After discussing the definition of the definite integral, let's move to calculate some definite integrals. As I said before, the rules of integration for definite integrals are the same as the rules for indefinite integrals. So to calculate the integration over 1/3 of x squared dx, first we need to apply the rule of integration of powers. So it gives x cubed over 3. Then we need to replace first x by 3, then x by 1, and it gives 3 to the power 3 minus 1 to the power 3 over 3. After the calculation, it gives 26 over 3. When the integral consists on sum or difference of many terms, as we learned in previous sections, we can calculate the integral of each term, term by term. So we can, for integration over 0 to for 4 minus x squared dx, we can write it as integration of 0 to 4 dx minus integration of 0 to x squared dx. Then calculating the integration over each term. 4 gives 4x. After replacing x by 2 and 0, we write 4 into 2 minus 0. Then minus the integration of x squared gives x cubed over 3. So replacing by the constant, we get 2 cubed minus 0 to the power 3 over 3. So it gives 16 over 3. For the third example, integral over 1 4 x squared plus 4x minus 60x. We need to calculate the integration over each term, so it gives x cubed over 3 plus 4x squared over 2 minus 6x. It's the definite integral over the boundaries 1, 4. So at first we need to replace x by 4, then subtract it from the values obtained when x is replaced by 1. And we get 88 over 3 plus 11 over 3, so it gives 33. After studying the previous examples, please do the following exercise. Evaluate the integrals in exercises 7 to till 18. Remember that all the rules applied to indefinite integrals are also applicable for definite integrals. Thank you.